This is AP Calculus AB, Worksheet 5-9, Definite Integral Rules. Numbers, I guess 1, all of these letters, we're trying to find the areas based on the graphs. So be very careful if you're talking about a graph of f or a graph of g. F is talking about this left graph, g is talking about the right side. I think everything on the left, oh yeah, there's a mixture of g and f on the left side, so I have to be careful. All right, so this is the integral between 1 and 1. Because these are the same exact coordinate, it's talking about no area whatsoever. It doesn't have any width to it, therefore the area is 0. I guess I move from A to B. I'm just trying to see if I should go all the way left to down. I guess I'm going to go A, then B, just go letter by letter. Between -3 to 1, between -3 all the way to 1 is talking about these two intervals together. Remember, if we're below the x-axis, it's a negative area, so it's really a -1 plus 3, which is a +2. Correct answer here is 2. All right, for part C, between -2 to 1, and then whatever that area is, we'll double it. Remember that 2 can come on the outside, so I'll do that. That 2 is really on the outside. You're doubling whatever the area is between -2 and 1. Between -2 and 1 is an area of 3. And therefore, I'm going to do, this is going to be 2 times 3, which is a total area of 6. For part D, we're going from -2 to 5 of g, from -2 to 5 there, for g. That means I'm doing 3 plus 5, which is 8, minus 1.5, which is 6.5. So this is just going to be 6.5. 6.5. All right, what about E? Okay, so again, I'm pulling that -3 out. So this is going to come out here. This is really going to be, what is the area between 3 and 5? We're going to multiply by -3. So from 3 to 5. So 3 to 5 is an area of -1 because we're below the x-axis. So this is going to be a -3 times a -1, which is a +3. What about for part F? Between -2 to 2 of g. Between -2 to 2 of g. That must be a typo because that doesn't make any sense whatsoever. So I'm going to go ahead and say that that one was probably supposed to be the integral from -2 to -2. That would make the most sense to me. Let me go ahead and make that change right now, and I'll make it in the document as well. You can't do this. It's the same point and same point, therefore it has no width for our area. Therefore the area here is going to be 0. All right, in part G, I'm going to go, oh, it's backwards. It's normally supposed to be from 1 to 3, but they swapped them. So I'll just make a note that these two are going to be swapped back to back. Therefore, our answer is going to be negative whatever our answer is normally between 1 and 3. So between 1 and 3, what letter are we doing? F. Between 1 to 3 is an area of 1.5. So now it's a negative 1.5. In pen, 1.5. Again, another way of thinking about this definite integral rule is you're going backwards, right? Instead of going from here all the way to here, and it's a positive 1.5, you're going from here all the way to here, and it's kind of like upside down, and this is really underneath the x-axis is 1.5. What about H? H is talking about a graph of G. Again, this 4, we'll pull it out and say, okay, you live on the outside. We're really going to do the integral between -2 and 1 of G. So between -2 to 1 is just an area of 3, and we multiply the 4 by that. So this is going to be 4 times 3, which is an area of 12. Moving on to part I. Okay, so this is F and G together. So this is, I'll write some notes. This is really the integral between -2 and 5 of F, plus the integral from -2 to 5 of G. All right, so integral between -2 and 5 of F. Have we done that yet? Between -2 to 5, 3, 4, 5. So it's everything over here. So this is a -1, so really those two add up to a positive 0.5, so it's 3.5. So I'll write a note here. This is 3.5 plus whatever the area is between -2 and 5 of G. Between -2 and 5 of G. Oh, we did that right here. So it's 6.5. So I can say over here, this is 6.5. And adding those together gives us 10. All right, what about J? Again, I have a -2 that I'm going to pull out, and I'm going to go from 1 to 4 of G. From 1 to 4 of G. So from 1 to 4 of G is 5. So this is really -2 times 5. -2 times 5, which is -10. I guess I can box it because there's other work there. What about for K? K is talking about, two different pieces here. So this is how you want to interpret this. You want to say that one of them is talking about the graph, the integral between 1 to 3 of F. And then you want to do the integral from 1 to 3 of 3. Again, there's a shortcut for this one, right? Whenever you have the definite bounds for a constant number, you're going to subtract the bounds, 3 minus 1, and then you multiply by whatever the number is inside, 3. And this is going to be 2 times 3, which is going to be 6 for this right piece. I need to figure out what this area is from 1 to 3 of f. Between 1 to 3 is just the 1.5. So this is really going to be down here, 1.5 plus the 6. So my total area is going to be 7.5. Nice. What about L? Ooh, backwards from 5 to 4. So really these should be backwards. So I'm going to go ahead and write a note. Those need to be swapped, which means my answer is negative whatever it normally would have been, between 4 and 5. So what do we have? Between 4 and 5. Between 4 and 5 is normally a negative 1.5. So I'm going to do, it's normally negative 1.5, but a double negative means it's a positive 1.5. And what about 4m? Again, we have two things happening at the same time. So I'm going to kind of pull out the 2, pull out the 3, and there's two different integrals. So here's what I really have. I have 2 times the integral between negative 2 to 1 of f minus 3 times the integral between negative 2 to 1 of g. All right, so none of these are backwards. So negative 2 to 1 of f. Negative 2 to 1 of f is 3. So we come down here and say this is going to be 2 times, in pen though, 2 times 3, which is going to be 6. And then I'm going to say minus 3 times whatever this number is over here, between negative 2 and 1 of g. Between negative 2 and 1 of g is just 3. So I'm going to come over here and say times 3 in pen, please. And that's going to be negative 9. And I'm running out of room, so let's grab our shrink ray. You get shrunken to about there. You guys can come up there. That turns into a negative 9. And again, that negative has moved down here, so I'm really adding these two pieces together and get a negative 3 for my final answer. All right, what about 4n? All right, two different pieces happening at the same time, and they're backwards. Oh boy, so backwards. So let me go ahead and change it to a negative integral between 1 to 4. The 2 is going to come out, and this is going to be a g. And then normally I would be writing a negative here. I'll go ahead and write it. This negative and this negative are the same negative, but I also need another negative out front because these bounds need to switch. So I'm going to do another negative bounds between 1 to 4 of 2. All right, so the way that we do the definite bounds of a constant is you subtract the bounds, 4 minus 1. 4 minus 1, and you multiply by whatever the number is in front. So this is going to be 3 times 2, which is going to be 6, and double negative, these are going to turn into a positive, right? So it's going to be plus that 6. What about the bounds from 1 to 4 of g? From 1 to 4, there's g, and from 1 to 4, it's an area of 5. So I'm going to come down here and say that the area is 5, so it's going to be negative 2 times the 5. That's going to be a negative 10, and negative 10 plus 6 is a negative 4 for our final answer. Done with the first page, on to the second. All right, so these are much, much more typical, although both problems will show up on the AP test. So we are given between 1 to 2, 1 to 5, and 1 to 5. Oh boy, this is interesting. Notice there's overlap. So this is f, this is f, this is a totally different g function. But within f, I know that between 1 and 2, it's negative 4, and between 1 and 5, which overlaps a little bit on here, there's 6, which somehow includes that negative 4. So just be careful here. First thing I'm seeing about A, same bound, therefore there's no area. You can say 0. This one, it's backwards, so I need to flip these around and say this is really negative the integral from 1. That was like a terrible integral though, wasn't it? Let's go ahead and make you a little bit better. Integral between 1 to 5 of g, and we already know between 1 and 5 of g is 8, so this is going to be negative 8. Negative 8. Done and done. What about for part C? Again, that 3 is going to come live out in front. So this is really, I can even rewrite it. It's a little bit pedantic, but you can say it's 3 times the integral from 1 to 2 of f. All right, well, I know the integral from 1 to 2 of f. It tells me 1 to 2 of f is negative 4. So it's going to be 3 times this negative 4. This is going to be equal to 3 times the negative 4, which is negative 12. I'm going to say equal to negative 12 for our final answer. All right, what about for D? Ooh, integral between 2 and 5. So we don't have the integral between 2 and 5 of f. Again, it's only dealing with f, so ignore the g for a sec. It's talking about these two pieces. And notice there is a 2 here, there is a 5 here, so somehow must combine these two integrals, and you're right to think that. So really what I want to do here is if I can somehow take this integral, the entire piece, the big piece, and subtract a tiny little piece, I can get the bigger piece. So let me do this maybe graphically so you can see what's going on here. So I have some function that maybe looks like this. It goes like, I don't know, maybe something crazy. I don't know. I know that right here at 2, something happens, and something happens here at 1. Doesn't it start at 1? Yeah, it goes from 1 to 2. So I'm going to say 1 to 2 and 1 to 5. So I'll say maybe 5 happens right there. I'm totally making up a picture right here. I'm going to say, okay, this chunk right here, I know that the integral, and I'm going to call this whole thing is f, by the way. So the integral between 1 to 2 is talking about this area right here. And that area right there, and I can even have my precision eraser on so you can make this really nice. You can say, okay, it's some function like this. And you can say that it's -4. I know that this piece over here is -4. And I know that if I add these two together, let me go ahead and say, if I add those two together, the integral between 1 and 5, I have that. I know that the integral between 1 to 5, the whole thing adds up to 6. I know the whole thing here adds up to 6. And the question that this is asking is, hey, between 2 and 5, what is this area right here? And you use a little bit of logic. You say, okay, well, this number over here plus this number has to add up to 6. But there's a mathematical way that you can say that. You can say that the integral between, how do we want to say it? The total minus the piece, right? So the total is the integral between 1 and 5 of f minus the integral from 1 to 2 of f. So the big piece minus this little piece will give you this piece that we wanted. It'll equal the piece that we wanted, this integral between 2 and 5 of f. Well, we know this, right? We know between 1 and 5, it tells us between 1 and 5 is 6. I can even use my graph up here. Between 1 to 5, it tells us the answer is 6. And if I subtract the integral between 1 and 2, it's this area of -4, -4. Oh, yes, you do have a double negative there. And this is going to be equal to the answer that I want. And 6 minus -4 is 10. And that logically makes sense. You probably were shouting out the answer before I even got here. Like, well, 10 has to be here in order for me to add 10 plus -4 to get a 6. So 10 is the right answer. You don't need to draw a graph. You just need to be able to do this math on your own. What about E? E is kind of that distribution property. You just say, okay, the integral between 1 and 5 of f minus the integral from 1 to 5 of g. Integral between 1 and 5 of f, 1 and 5 of f is 6. So come down here and say this is 6 minus the integral between 1 and 5 of g. 1 and 5 of g is 8. So come down here and say this is -8. 6 minus 8 is -2, done and done. What about this one? Ooh, this one is just using a few different properties at the same time. So the 4 is going to come live out in front, and this is going to be really 5 times the integral between 1 and 5 of f minus integral between 1 and 5 of 2. And this one is pretty easy because we know that integral between 1 and 5 of f, that's right there, we got 6. So I know this is going to be 5 times 6, and 5 times 6 is 30. We have to subtract some stuff. So how do I do a definite bound? So again, this is a shortcut, right? You subtract the bounds, 5 minus 1, I'll do this, 5 minus 1. You subtract the bounds and multiply by whatever the number is, times 2. And this is going to be 4 times 2, and 4 times 2 is 8. So I can say 8, and I can subtract these, and I get 22 for my final answer. Oh boy. All right, moving on to another problem. And interestingly enough, I'm like, why? Just something felt wrong. I'm like, that's a 4. Why did it randomly change into a 5? I have no idea. And I have my precision eraser turned on, stroke eraser. There we go. Sorry about that. Let me make this better. This is going to be 4. There. 6 and 4 is 24, and 24 minus 18 is 16. That feels a lot better. All right. And I can move on to number 3. All right, so we got another bunch of pieces. So what do you notice here, Mr. Sindel? Well, I notice that this is f, and this is h, or some random function. I also notice with my f, there's overlap. This is the total piece. This is the last 2 like inches of that graph, but this is like the total one. Interesting. I know that the very right 2 pieces between 7 and 9 is 5. Okay, so I can visually see what's going on here. Now I can attack these problems. Okay, the integral between 1 and 9 is talking about this integral between 1 and 9. That -2 is going to come live out in front, right? We're going to say this is really -2 times the integral between 1 to 9 of f, and we know that the integral between 1 and 9 of f is -1. So this is going to be equal to -2 times a -1, which is a +2. That was a terrible rectangle. All my rectangles haven't been the best, but I like going fast. All right, what about for part B? Part B is, again, the distribution property of the integral, right? You can say the integral between 7 to 9 of f plus the integral between 7 to 9 of 3. Well, I know the integral between 7 and 9 of f because it tells me by definition that it's equal to 5. So this is going to be 5 plus, okay, I don't have any information about that, but it's a definite integral of a constant. So again, you subtract the bounds, you say 9 minus 7, and then you multiply whatever the number is times 3 in this case. 2 times 3 is 6, so this is going to be 5 plus 6, which is 11. All right, moving on to part C. we have, again, distribution property. So the 2 is going to come live out in front. You're going to say the bounds are between 7 to 9 of f minus, again, 3 is going to come live out in front. The bound are still 7 to 9 of h. And both of those are fully defined, right? Between 7 and 9 of f, it tells us 7 and 9 of f is 5. So this is going to be 2 times 5, which is 10. Minus, okay, and then what about 7 and 9 of h? 7 and 9 of h is 4, so we can come over here and say 3 times 4, and 3 times 4 is 12. When I subtract those two, I get negative 2. All right. Oh boy, 3 more problems and we're done. Oh, you guys are backwards. So it normally goes smaller to bigger. So this needs to be negative integral between 1 to 9 of f. And we happen to know that the integral between 1 and 9 of f, which we've seen over and over, is negative 1. So it's a negative negative 1 is equal to a negative negative 1, which is equal to a positive 1. What about over here? Finally, between 1 and 7. I knew it was going to happen because it's only talking about f. So this is h, ignore u. Notice that it's being cut off right here. So again, I can illustrate this with a picture to the best of my ability. I'm going to say maybe it's something that looks like this, where I have a function right here. I'm going to say that this spot right here is 7, this spot right here is 9, and this spot right here is, it needs to start at 1, darn it. Here, I'm going to cheat a little bit. I'm going to go like, there, now it starts at 1. Haha, this spot right here is 1. All right, so I know that all together, all of this area adds up to whatever the total sum is. So the total sum between 1 and 9 is negative 1. The whole thing adds up to a negative 1. But I also know that between 7 and 9, this piece right here adds up to 5. This piece up here adds up to 5. So there's my picture. So here's what I'm really after. What is this area right here, right? That's supposed to be a question mark. What is this area between 1 and 7? That's what the question is asking. So how do I do that? You do, logic, and you're like, oh, well, now that I have a picture, this is clearly negative 6. But how would you do this without a picture? Making that picture is kind of hard. I can do it because I've been teaching AP Pre-Calculus or AP Calculus for a while now. But what would you guys do? You say, okay, well, I really have the integral between 1 to 9, which is like I kind of think of that as like the big piece of f. And you have to subtract the integral between 7 and 9 of f. That should give you the integral between wherever the bounds are subtracted. 1 and 9 got cut off, the last two pieces got cut off, and now I only have from 1 to 7, which is what I'm after. This is what I should have written automatically. I did too much by writing this. And I can say now this is going to be 5. Wait, that's not the total. The total is negative 1. Negative 1 minus a 5. And that will give me my final answer, which is a negative 6 for my final piece. All right, what about over here? So 2 things happening. First of all, these bounds are wrong and they need to be switched. So it's going to be negative whatever my answer is. I'm going to put giant parentheses here. And I really have the integral between 7 to 9 of h minus the same distributed bounds 7 to 9 of f. Haven't I done that one before? Kind of. They've all been multiplied by weird stuff. But 7 and 9 of h, 7 and 9 of h is 4. So come down here and say that's a 4 minus, and then 7 and 9 of f, 7 and 9 of f is 5. So 5. And then I'll subtract those two. And once I subtract the two, I'll have a negative. So 4 minus 5 is a negative 1. And then I'll multiply by a negative. So the answer here should be a positive 1. And that does conclude the worksheet. All right, thanks for watching, guys. There is page 2, the solutions, and there is page 1. Thanks for watching.